Hey everyone, and welcome to another deep dive. Today we're looking ahead to the AI landscape of 2025 and beyond.
Sound pretty futuristic.
It is. We've got an article here called Building the AI Platform of Tomorrow by Phil Trikovich, SVP at Tintri.
Okay, so what kind of future is he painting?
Well, he's predicting some pretty major changes, like, get this, saying goodbye to the classic three-tier architecture.
Whoa, hold on. The three-tier architecture, the one that's been the backbone of IT for like forever.
Yep, that's the one.
Hmm.
He thinks it might be on its way out, but we'll get into that a little more later.
Okay, that's a big one. So what's driving these changes?
The article really dives into how AI is fundamentally changing the game. And one of the big points he makes is that we're witnessing the end of the Boolean compute era.
The Boolean compute era.
Yeah, so you know how our computers currently work? Everything's based on ones and zeros, right?
Mhm.
Those binary states. On or off, yes or no.
Right, the basic building blocks of computing.
Exactly. But AI is demanding a whole new level of complexity. It's not just about simple yes-no calculations anymore.
So instead of a light switch, it's more like a dimmer switch with a whole range of possibilities.
That's a great way to put it. AI needs systems that can handle nuance, ambiguity, and those shades of gray that exist in the real world.
Makes sense. But how do we move beyond this binary system that's been so fundamental to computing?
Well, Trikovich argues that we need specialized hardware that's engineered specifically for AI tasks.
Specialized hardware. You mean like custom-built chips designed for things like natural language processing or image recognition?
You got it. Instead of a one-size-fits-all processor, we're moving towards tools designed for specific jobs. Think of it like this.
Okay, I'm listening.
If you're a surgeon, you wouldn't use a butter knife for a delicate procedure, right? You'd need a scalpel.
Makes sense.
Yeah.
The right tool for the job.
Exactly. And that's what's happening with AI hardware. We're seeing the development of things like GPUs, DPUs, and FPGAs.
I've heard those terms before. They're all about parallel processing, right? Handling massive amounts of data simultaneously.
Precisely. And that makes them incredibly efficient for those complex AI calculations.
So, to bring it back to the real world, we're talking about the technology that's powering things like self-driving cars or enabling those super realistic video games.
Absolutely. And it's also what's behind those inference applications that are becoming increasingly common in various industries.
Inference applications.
Mhm.
Okay, can you break that down a bit? What exactly are they?
Okay, so let's say you've trained an AI model to recognize patterns in medical images, maybe to detect signs of a particular disease.
Okay, I'm following.
Now, you give the model a new patient scan. The inference application is the part of the AI that analyzes that scan, applies its learned knowledge, and makes a judgment.
So it's not just crunching numbers, it's actually using that knowledge to make a decision that could have real-world implications.
Exactly. It's like the thinking part of the AI. And because these inference applications are handling such complex tasks, they need that specialized hardware to run efficiently.
That makes sense. So we've established the why AI needs specialized hardware. But the article also talks about 5 key trends to watch in this evolving landscape, right?
Yeah.
Where do we even begin with that?
Well, the first one is a bit of a bombshell. Trikovich suggests that the traditional three-tier architecture, the one we talked about earlier, might be on its way out.
Okay, so he wasn't kidding about that. But how can he say that? It's been the foundation of IT for so long.
He argues that it just can't keep up with the demands of AI. With those separate layers for presentation, application logic, and data, it creates bottlenecks when you're dealing with these massive data sets and complex processing needs.
So the old system is kind of like trying to cram a square peg into a round hole.
Exactly. It's just not built for the demands of AI.
So if the three-tier architecture is on the way out, what's going to replace it? What does Trikovich propose?
Well, he doesn't offer a specific model, but he emphasizes the need for a complete rethink of how we design systems.
Complete rethink. That's huge.
It is. We need architectures that are more flexible, scalable, and optimized for these AI workloads.
So it's not just about tweaking the existing systems. It's more like we need to build entirely new cities instead of just adding a few lanes to the existing highways.
That's a great analogy. And you know what? That brings us to the second trend. The rise of function-specific edge devices, which could play a key role in this whole architectural evolution.
Okay, function-specific edge devices. Tell me more.
Well, imagine a world where every device is hyper-efficient and only uses power when it absolutely needs to.
That sounds like something straight out of a sci-fi movie.
Maybe, but it's closer than you think.
All right, I'm intrigued. Let's dive in. So with these function-specific edge devices, are we talking about those specialized chips that live right where the data is being generated instead of having to send everything back to some central server?
Exactly. Think about a smart security camera. Instead of sending all that footage to a server to be analyzed, it can process everything right there on the spot.
Oh, I see. So it only sends an alert if it actually detects something suspicious.
Right. That's edge computing in action. And it's not just about efficiency, it also reduces latency.
Ah, those annoying delays.
Yep. Those can really make a difference in those real-time
Oh,
applications.
I see what you mean. Like in self-driving cars or medical monitoring systems where every millisecond counts.
Exactly. But it makes you wonder, though, what about the impact on power consumption?
Yeah, wouldn't all those devices processing data constantly just drain energy?
That's a great question, and it's something that Trikovich addresses directly. You see, traditional systems often waste a lot of energy because those processors are frequently idle, just sitting there waiting for data or instructions.
Okay.
But function-specific edge devices, they can be designed to power down when they're not actively processing.
Oh, so they're only using energy when they absolutely need to.
Precisely, and that leads to significant energy savings.
So we're talking about making AI more efficient, but also more sustainable.
Exactly. Which brings us to the next trend on Trikovich's list: portability and decentralization of applications.
Okay, portability and decentralization. So is he talking about a future where, like, my AI-powered medical records could be accessed and analyzed by any doctor anywhere in the world instantly and securely?
You got it. That's the kind of seamless integration we're talking about. And it's especially critical as those AI models get more and more complex and those data sets grow larger and larger.
So instead of being tied to a specific device or location, AI applications could become more adaptable, more fluid.
Exactly. Imagine your personalized AI assistant. The one that manages your schedule, recommends movies, helps you write emails. Well, now it can seamlessly transition between all your devices, accessing all your data and your preferences no matter where you are or what you're using.
Okay, yeah, that would be super convenient. It's like having a digital brain that's not limited by any single device.
Right. And this kind of portability, it has huge implications for other fields too, like healthcare. Think about it. A world where your entire medical history, scans, test results, genetic data, all of it, it could be securely accessed and analyzed by any doctor anywhere in the world, instantly.
Okay, now that's a powerful vision. It could totally revolutionize healthcare as we know it.
Absolutely. But it also makes you think, with all that data moving around, how do we make sure it stays private and secure?
Yeah, you don't want that sensitive information just floating around out there vulnerable to breaches.
Right. So portability doesn't mean sacrificing security.
It actually makes robust security measures even more important.
Exactly. We need systems that can protect that sensitive data as it moves between all those different devices and locations.
So things like blockchain-based authentication, homomorphic encryption, all those cutting-edge technologies.
Exactly. It's about building a whole new security infrastructure, one that's as dynamic and adaptable as the AI applications it's designed to protect.
Makes sense. So we've talked about efficiency and portability, but what about the cost of all this?
Well, that brings us to trend number 4: power consumption and cost optimization. Because as AI gets more and more sophisticated, we need to make sure it doesn't become a huge energy drain.
And a financial burden.
Exactly.
So we've talked about how specialized hardware can make AI processing more efficient.
Right.
But is that enough?
Mm.
What are some of the other things that contribute to those high energy demands?
Well, one of the big factors is the design of the AI models themselves.
Oh, okay.
Some models are just inherently more energy intensive than others, depending on how complex they are and how much data they need.
I see.
So researchers are actually exploring new ways to develop more energy efficient models without sacrificing that performance.
So it's all about finding that balance between power and performance.
Right, making sure that AI systems are both powerful and sustainable. And there are a few strategies that they're using to try to achieve this.
Like what?
Well, one approach is called model compression. It's kind of like if you were packing a suitcase.
Okay.
Instead of taking everything you own, you pick out just the essential items, right?
Right, to reduce the bulk and weight.
Exactly. So in the context of AI, it means simplifying or streamlining those models, making them leaner and more agile.
Without sacrificing their accuracy.
Right. They can still perform their intended tasks. But it's not just about the models themselves. We also need to optimize the entire infrastructure that supports them.
Ah. So things like data center design, cooling systems, Even the programming languages used to develop those AI applications.
Exactly. It's all got to be considered in terms of energy efficiency.
So it's a pretty holistic approach then, looking at both the hardware and the software aspects of the AI systems.
You got it. And that brings us to the fifth and final trend: integrating those increasingly advanced AI models. Because AI research is moving so fast, we need to make sure our systems can keep up.
It's not just about handling all that data then, it's about keeping pace with the evolving intelligence of those AI models.
Exactly. But it's not easy.
Well, what are some of the challenges involved in integrating these ever smarter AI systems?
Well, one of the biggest challenges is scalability. As AI models become more complex, they need massive amounts of data and processing power for all that training and validation.
Right, and that can really strain those traditional data centers and computing resources.
Exactly. So we need to build systems that can adapt to the growing demands of these advanced AI models.
So what are we doing about it? What are some of the ways we can address this?
Well, cloud computing has emerged as one of the most promising solutions. Cloud platforms offer tons of computing resources, and they can be scaled up or down as needed.
Oh, so it's like having this virtual powerhouse at your disposal.
That's a good way to put it. And cloud platforms also offer a whole bunch of specialized services and tools that are designed for AI development.
Oh, okay, cool. So that makes it easier for everyone to get involved.
Right. It's making AI more accessible to a wider range of people and organizations.
So it's not just about big tech companies anymore.
Not at all. And beyond cloud computing, researchers are also exploring new hardware architectures that are specifically designed for AI. They're moving away from that traditional CPU-centric model and embracing specialized processors like GPUs and TPUs.
GPUs and TPUs.
Yeah, they're much better suited for handling those parallel processing demands of AI.
So instead of trying to fit AI into these existing systems, it's about building something completely new.
Exactly. Optimized from the ground up. And as AI keeps evolving, we can expect to see even more innovative hardware and software solutions. It's a really dynamic field.
There's so much potential for innovation. This has been super interesting. What are some of the key things you want our listeners to remember?
I think the biggest takeaway is that the future of AI is about more than just the technology itself.
It's about what it all means for us, right?
Right. It's about understanding how these technologies are going to impact our lives, our businesses, our entire society.
So we all need to be part of this conversation.
Absolutely. We need to be actively involved in shaping this AI-powered future to make sure that it benefits everyone. And speaking of shaping the future, I think it's time for our final thought-provoking question. Something to leave our listeners pondering as we wrap up this deep dive.
I like it. Hit me. Okay, so here's something to think about. If all this keeps going, all these advancements in AI hardware, if they continue in the direction Trickovich is talking about, what could happen?
What do you mean? Like, what's the end game here?
Yeah, what completely new fields or industries might emerge that we can't even imagine right now?
Oh, wow. That's a big question.
It is, right.
It's like back when the internet was first becoming a thing,
Mhm.
we knew computers could communicate, but we had no idea the impact it would have.
It's like we're standing at the edge of something similar with AI.
So what are we talking about here?
And well, think about it. What if we could create personalized education systems tailored to each student's unique learning style?
Yeah, or AI-powered tools that could unlock the mysteries of the human brain.
Or accelerate scientific discovery in ways we can't even comprehend right now?
It's pretty mind-blowing when you think about it.
It really is. But with any powerful technology, we've got to be careful.
Oh, absolutely. Ethical considerations have to be front and center.
We need to make sure AI is developed responsibly.
And address those concerns about bias and fairness.
And accountability, too. And we've got to have these open conversations about how this is all going to impact society.
Right, like how will widespread AI adoption change the workforce, the economy, our understanding of what it means to be human?
Exactly. These aren't easy questions.
Nope. They require careful consideration and a lot of collaboration. It's not just about building the technology, but shaping the future we want to create with it.
And everyone needs to be part of that conversation.
Technologists, policymakers, business leaders, and just everyday people.
We all have a role to play.
This deep dive has been amazing.
Yeah, we've covered a lot.
We got a glimpse into the future of AI and all those challenges and opportunities that are ahead.
It's a really exciting time to be following all this.
It is. And to our listener, thanks for joining us on this journey.
Keep learning. Keep asking questions.
And remember, the future is what we make it. So let's build an AI-powered world that works for everyone. Until next time, happy diving.